Today we move on to another chapter in Design for Environment. This time we're going to look at process, especially process design. Last class we talked about product design. Now we're going to talk about process design, and in both cases my goal is not to teach you how to design the product or the process. By that I mean for the function, but more so how environmental considerations can be incorporated during the design stage. So let's go back a little bit about this product process design and just revisit it so that it's fresh in our mind. So what I have here is a cell phone, a smartphone. All of you have one. This is a product, and we use this because we can make calls anywhere, anytime. We can also, it can be used for many other things. It serves as a GPS device. It serves as a camera. You can surf the net. You can do a whole lot of things with your smartphone. So it's a product, and all of what I just mentioned in terms of what it can do are things customers want. Now, the cell phone has to be made, and that's where the process comes into being. So you can see there is a plastic outer casing to protect this if I should accidentally drop it, and so it doesn't break or crack. It's got a glass screen. It's got many plastic molded parts, and inside there's a lot of microelectronic chips and circuitry. So that's what makes a cell phone, smartphone. Each of these, the integrated circuits have to be made, the plastic molded parts have to be made, the glass has to be made, and they all have to be assembled. So each of these are like operations, and they are done in a particular sequence, and then the result is the cell phone. So let's start off with a definition of an industrial process, because that's what today's class is all about. So the more precise term is industrial process. So today we're going to talk about industrial process design and operation, and what things we may do to make sure that these happen with least negative impacts to the environment. So it's called IPDO, Industrial Process Design and Operation. So an industrial process, as is stated here, is defined as a sequence of operations that produce a technological result. That could be a cell phone is a technological result. The result could be the manufacture of a pencil. So that's what it is, and it's a sequence of operations. It's a lot more complicated than I might be suggesting. Process design, like product design, is an extremely complex and challenging activity, and the designer has to do many things. The first of these is to make sure that you produce the technological result, which is manufacture the smartphone. But it's a whole lot of other things you have to do. You have to make sure you make these high precision products within tolerance limits. Tolerance limits, right? So when we make anything for the folks in the shop floor, suppose a hole has to be drilled. It's 1/2 inch in diameter. It's impossible to produce multiple parts with exactly 1/2 inch diameter. So we allow a little bit of leeway. They can be a little inexact. They can be smaller than 1/2 inch, maybe 0.495, or they could be as large as 0.505. And that range from 0.495 to 0.505 is called the tolerance, because we know anything made within that size will still work. And it's not easy to produce parts to even within the tolerance. So they have to do that. They have to make sure that the process is reliable over time. What does that mean? Well, it means that if you made chicken soup on a particular day and it came out really well, you make it the next day, it comes out well, third day it comes out well. Now towards the weekend you decide to invite your girlfriend's parents and extended family, and you make this famous chicken soup of yours, and it's a disaster, right? What happened? Well, there was no process reliability. You weren't jotting down. You were given to flights of inspiration, right? So the amount of salt and chicken stock and whatnot, you are winging it. for a process to have reliability, it means that it should perform day after day after day, month after month, year after year, consistently, producing the same product with the same attributes, the same quality. So you have to make sure you have a reliable process. You have to have a process that's safe for the operators. There are lots of people around the process who maintain the process, troubleshoot it, right? And so it has to be safe. It cannot present a danger or hazard of some sort. Maybe high radiation, maybe high temperature. It's releasing gaseous products that is not good to inhale. It's using deadly chemicals. And another thing is to make sure the process is modular, meaning that you can scale the process. A modular process is one which can be increased or decreased without having to completely overhaul the whole thing. Modular products are also, processes are also good because if some part of the equipment malfunctions, you can just take that out and replace it. It's just like your automobile, right? If your tail lights have an issue, you don't have to buy a new car. You just change that. It could be something to do with your engine. They just replace the O-ring or washer. You don't have to change the engine. So they are modular. In addition, if this seems a lot, there are still a few more things. Designers have to make sure that the process is designed for a low first cost. They also have to design the process for low operating cost. So what is the difference between first cost and operating cost? Well, take your car, right? When you go to the car dealership and you buy the car, that's your first cost, the initial cost. And so how much is it? Is it very high? Is it low? So we want processes that cost low to install and kick off. But then you have to run it on a daily basis. And there's a cost associated with it. You know very well when you buy a car, it's not that you just pay whatever 18 or 25 grand. You are maintaining the car, you have to fill gas, you have to do inspection, you have to change oil and filter. There's so many things. So there's a cost of ownership. And that's what we mean by operating costs. So you have to try to optimize all of this. So lots of things to do, right? Now add into this mix industrial ecology or design for environment. There are some additional requirements placed on the process designer. First, they have to prevent pollution. A lot of processes, the favorite image in everybody's mind of an industrial process is the smokestack, which is spewing out black smoke, right? So pollution prevention. The second thing is to minimize risk to the environment. It could be in the form of pollution or depletion, or some scarce resource like water, or some choice metals that are fast depleting. And the third and important is to design the process from a life cycle perspective, not just what happens within the factory walls, but what happens before, what follows, so the entire life cycle. So that's the focus of today's class is what do you do to ensure a process is doing well from a life cycle standpoint, environmental impact standpoint.